Hi, so this is a run through of the practice questions from the Forces section of Roy White's excellent GCSE physics book. Check this out if you haven't used it. It's an excellent text, it's got lots of great graphics and pictures and good explanations, lots of things about the prescribed practicals and stuff like that. This stuff comes from the practice questions for Forces, page 22. And in this last section we're doing questions 8 to 10. Question 8. The boat in figure 2.22 has a mass of 15,000 kilograms. The force of friction on the boat is 12,000 newtons and it is accelerating at 2 meters per second squared. Calculate A, the resultant force on the boat. Okay, so you can see here that we have a forward force and a frictional force, and it's accelerating at 2 meters per second. So there must be an unbalanced force because you can't get acceleration unless there's an unbalanced force. So we need to think about what the resultant must be. And the resultant force, remember, the resultant force in this case is the one that causes the acceleration. So it's the F in F equals ma. So we know M and A. M is 15,000 kilograms, A is 2 meters per second squared. So F must be 30,000 newtons. So this resultant force is also the outcome of a battle between the forward and backward forces. So the forward forces here are winning by 30,000 newtons. And so we can write an expression for the resultant force using the forward and backward forces. If we take the forward one to be positive, take the backward one to be negative, add them together, they must also equal 30,000 newtons. So if we call the forward force the pull of the engine, and the frictional force is going to be minus 12,000, we can say that 30,000 equals P added to minus 12,000. So we get P on its own by adding 12,000 to both sides, and that means that P would have to be 42,000 newtons. So remember what a resultant force is. It's the sum of all forces taking account of their directions. So if we're taking forward to be plus, like this, then P goes in as just a positive value. The 30,000 resultant is also a positive value because it heads in the same direction as A. F and A in that equation always point the same way. And the 12,000 has to be negative. So this has to be minus direction here. So the resultant 30,000 is the sum of P and the frictional force. And the frictional force has to go in as negative because it points the opposite way to the direction we took to be positive. Question 9. An object falls from rest and strikes the ground exactly 1.5 seconds later. At what speed does it hit the ground? So we'll assume this is happening over the Earth, and so the G, acceleration due to gravity, we can take to be 10 meters per second squared. So falls from rest means that U equals 0. V is an unknown. A is going to be G, and we can take down to be positive here because everything in this first part is downward, so it's easier if we take everything to be positive in the downward direction. We don't know S, but we do know that T is 1.5 seconds. So we need an equation for V, and A is V minus U over T, and multiplying by T, AT would equal V minus U. And adding U to both sides, we'll get V on its own. And so this is our expression for V. Just fill in now with 0 for U, 10 for A, and 1.5 for T. And V is going to come out to be 15 meters per second. Part B, a ball is thrown vertically upwards at an initial speed of 24 meters per second. And part 1, how long does it take to reach its maximum height? So we've got an initial speed here of 24, At maximum height, it will stop before falling back down, and so its final velocity up there is going to be 0. So the ball's going to come up, slow, reach its highest point, and then come back down. But at this highest point, it's going to stop instantaneously. It'll stop, so boom, slowing, and then falling, boom, slowing. So it'll slow to 0 here, and that's what we want to think about. So we're going to get a u of 24 meters per second upward, v equal to 0. And A will equal gravity, which is going to be minus 10 meters per second, because it points down, and that means it has to have the opposite sign to the 24 meters per second, which we took to be positive. So we start making out our UVAS list. U24, V equals 0, A equal to minus 10, S we don't know, that'll be the height it rises to, and T we're being asked to find. So A equals V minus U over T. And so T is going to equal V minus U over A. And so that's going to be 0 minus 24 over minus 10. And that's going to give us a time of 2.4 seconds. So part 2 of B asks us to find this vertical displacement. And so this is a uniform accelerated object. Therefore, the average velocity can be found from the average of U and V. Because the velocity time graph would be a straight line. It's uniform, therefore the mean of those can be the average velocity in this case. And so the displacement is going to be the average velocity times time. So average velocity is like u plus v over 2, and then multiplied by the time. So that's going to be 12, the average velocity of 24 and 0, times 2.4, which gives us 28.8 meters. Question 10. The friction force opposing the motion of a locomotive of mass 25,000 kilograms is 100,000 newtons. What forward force must the locomotive provide if it is to travel along a straight horizontal track at a steady speed of 1.5 meters per second? Squared. That must be a mistake. That shouldn't be squared. At steady speed of 1.5 meters per second. That should probably be. Okay, so let's fix that and put some information onto the diagram. So we're told that it's moving at a steady speed. And Newton's first law tells us that if an object is moving at a steady speed, it has balanced forces on it. So you would just state why you're making this assumption, but you're basically saying that the forces are balanced, therefore P has to equal 100,000 as well. So part B, it says then, what is the acceleration of the locomotive if the forward force now increases to 175,000 newtons and the friction force is unchanged? And this is a common kind of problem where they give you a steady speed situation and then they give you the acceleration situation. This is really like the first part is about Newton's first law, the second part is about Newton's second law. So remember, first law is about are the forces balanced? The second part is what do I do if they're not balanced? And we have an equation for that, F equals ma. So the diagram for part B is like this, where we've got 175,000 newtons forward, 100,000 newtons backward, and we're wondering about this acceleration. Okay, so it's clearly going to be in the forward direction because it's obviously winning. We need to find a resultant force. So the resultant taking forward to be positive is the sum of these, with the forward one plus and the backward one negative. So it's positive 175,000 added to negative 100,000, and that's going to give us a positive 75,000. And that's the resultant force. Remember, it's the resultant force that makes the acceleration happen. We had no acceleration before because we had a balance of forces, so we only got steady speed before. We do have acceleration now, and it's caused by the imbalance, and it's the bit of imbalance that is the F in F equals ma The F in F equals ma is the resultant, the unbalanced bit of force. So that goes into our F equals ma along with the mass of the train. So A is going to equal F over m, 75,000 over the 25,000 kilograms of the mass of the train. And that's obviously going to give us an A value of 3 meters per second squared. And that's the end of those questions. Thanks for watching.